Section 1.6 deals with the continuity of the trigonometric functions, and we developed a couple of important limits which will be crucial in the development of the derivatives of derivative formulas for trig functions we'll see in chapter 2. Okay, first of all, let's take a look at the different trig functions. All right, and here we have a graph, and this is a graph of sine, and it's clear that sine is a continuous function. Same thing if we look at cosine. Cosine is continuous. Tangent is continuous, except at the odd multiples of pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, which you can't see, negative pi over 2, negative 3 pi over 2. But basically it's continuous on its domain. These values at pi over 2 and 3 pi over 2 and such are not in the domain of tangent, so tangent is continuous on its natural domain. The same is true for cotangent. Cotangent is continuous except at multiples of pi, 0, pi, 2 pi, negative 2 pi, and so on. And that's its domain also. So tangent cotangent is continuous on its domain. The same is true for secant, is continuous on its domain. All right, notice the red dotted lines are places outside of the domain of cosecant, and outside of secant, and the same is true for cosecant. If we look at exponential functions, their domain is the entire real line from negative infinity to infinity, and if we notice, these functions are also continuous on their domain, as are the logarithmic functions. This is the natural log, and its domain is the positive numbers. It's continuous on there. There's no breaks. So in essence, what we want to say is that if we look at any of the trig functions, the exponential functions, and the logarithmic functions, all of these are continuous on their domain. Okay, let's use this. Okay, let's suppose we want to take the limit as x approaches the square root of pi over 4 of tangent of x squared. Okay, well, first here's the thing. Let's take a look at what's happening to this x squared. If I look at the limit as x approaches the square root of pi over 2 of x squared, that's going to be the square root of pi, not pi over 2, pi over 4 squared, which is pi over 4. And this is pi over 2, so pi over 4 is right here. Pi over 4 is in the domain of tangent, so the tangent is continuous at pi over 4. That means then, as long as a function is continuous at that place, that the limit as x approaches the square root of pi over 4 of tangent of x squared, since x squared is approaching a value in the domain of tangent, tangent is continuous, and basically we can move the limit inside of the function. That's a property of continuous functions. Where functions are continuous, the limit can be moved in or out of them. Okay, so this would be equal to the tangent of the limit as x approaches the square root of pi over 4 of x squared. And we saw a second ago that that was the tangent of this limit, which is pi over 4, and the tangent of pi over 4 is 1. So this limit would be 1. Let's take a look at another example. How about the limit as x approaches square root of pi over 2, tangent of x squared? If I look at this limit as x approaches the square root of pi over 2 of x squared, okay, this the function inside, that limit is, I think you can see, is going to be pi over 2, square root of pi over 2 squared. And notice pi over 2 is a point of discontinuity for tangent. So in order to examine this limit, we'll have to examine it a little more closely. Let's consider the limit as x approaches the square root of pi over 2 from the left of tangent of x squared. Well, if x is to the left of the square root of pi over 2, x squared is going to be a little smaller than pi over 2. So if we're a little smaller than pi over 2, we're here as we get closer and closer to pi over 2, because x is getting closer and closer to the square root of pi over 2. Notice that this limit is going to, the tangent is going to get bigger and bigger, so this limit would be infinity. All right, if we approach from the right, all right, if x is a little bit bigger than the square root of pi over 2, x squared will be bigger than pi over 2. So we'll be over here, and as x gets closer and closer to the square root of pi over 2, x squared will get closer and closer to pi over 2, but on the right-hand side, and so this limit would be negative infinity. Oops. And so what can we say about the limit that we were asked about? The limit as x approaches the square root of pi over 2 of tangent of x squared, this limit does not exist.